Good afternoon. Good afternoon. Hope all is well. Hope everyone's doing all right. Giving everybody a chance to get in. Still have somebody connecting with audio. Just give them a few more seconds.
Hey, can I ask a question really quick?
Sure.
So, for the test, I know you said if we do the test reviews that we get an extra 5 points. Is that correct?
Yes.
Okay, so is it on the test or is it just as the total?
It'll just be added to your test. Like, so basically I have to add up all your tests and divide it by 2. I mean, divided by however many tests we have anyway. So I'll just put it in the pool of points for your test. So it
Okay.
will be able to affect any of your tests.
Thank you so much.
Yep, no problem. All right, looks like everybody is in there and in here and connected. So once again, good afternoon. Hope all is well. Hope everyone's doing all right. Hope everybody had a great weekend and ready to get this session going, this week going. So last week we did 4142. We didn't do anything Wednesday because I decided to give you a free day to ask, questions and just have a break before we keep pushing forward. So we did 4142, we do 43 and 44 today, and that will close out chapter 4. And then we'll talk about how we're going to move forward with that. So 4.3, modeling linear trends. Last class, we ended with the correlation coefficient. And here we're starting with the regression line. So it's a tool for making predictions about future observed values. It provides a useful way of summarizing a linear relationship. Give me a chance to write that before I scroll up. All right, so generally the equation of the line is y equal to mx plus b, it's the slope-intercept form, where m, that's the letter or the number that's attached to your x, that's your slope. Let me do this. Write this a little better. Of course, if I scroll up, let me know if you're still copying.
I'm still copying.
No, that's all right, so I'll pause right here. All right, scrolling up some. Anybody holding on to the black? All right. So, as I mentioned before, the general equation of the line that fits the format that we're going to lean on is y equal to mx plus b. But for stats, for this class, it's going to be y equal to a plus bx. Same two elements, it's just that b is going to represent our slope and a is going to represent our y-intercept. All right, so in the chat, it says x means dead. Right, we're going to be plugging in the value for x. Yep. We're going to plug in for x and get out y. Yep. So, but we're going to have specific data values that we're dealing with. Yep. So you're right along what we'll be going into. I'll scroll up. Let me know if I go up too far. So we're looking at the regression line in context. And is it a equal y minus? No, that's y-intercept. That's just y-intercept. So that's not a formula. That's just how you label it, your y-intercept. So purple. See if I can get all of this in here so you can. Okay, now we're going to start. Also right there. Okay, so the regression line in context. So our first example, looking at this, we have a college instructor with far too many books on his shelf is wondering whether he has room for one more. He has 20 millimeters of space left on his shelf. He can tell from the online bookstore that the book he wants has 598 pages. The regression line is. So I'll give you a second to copy this down before we scroll up. Yes, that's 20 millimeters. So I'm gonna scroll up some right there. Hopefully, anybody, if I scroll too far, let me know. So the regression line is, we have the predicted width equal to 6.22.366 pages. Let me erase these circles. Now, will the book fit on his shelf? So the way this is set up, so in MathLab for this this class, a lot of times they'll actually have words to represent, you know, how we had Y and X. So in this case, the predicted width is your Y. Oh, what is this? What's going on? Okay, I did that. Okay. So predicted width is your Y, and then X are your pages. But they gave us this whole equation for our regression line. So once again, they gave it to us. We'll talk about how to find the regression line. But in this example, they actually, you know, gave it to us. So you see my statement down here in dark purple. It says the regression line is based on previous observations. What's going to happen is that we're going to have some observations, and then from there, we'll be able to create this regression line that then we can predict how something else will occur based on the numbers that we have. So in this case, we want to predict the width of a book based on the fact that we have 598 pages. And once again, these numbers would have, or this equation would have been generated based upon previous observations. So he looked at the rest of his bookshelf and done his calculation, found this regression line. Then he can plug in 598 and predict what the book should be about, how thick the book should be. So this next statement right here, because of those previous observations, you are able to make a prediction on future observations. So that's what I was stating there. Just a second to finish that, and then we'll go ahead and finish off the problem. All right, can we scroll up? So like I mentioned, we took that 598, plug it in for pages in the formula so we can get a predicted width. So the 6.22 plus 0.366 times 598. And we plug that into the calculator, you should get 28.1068. And so according to our regression line, the predicted thickness should be 28 millimeters. So this book should not be able to fit on his shelf, because remember, all he had left was 20 millimeters, if I'm mistaken. Yep, 20 millimeters.
Hey, can I ask a question real quick? It's kind of a dumb question. How did you get the 21.8868? Did you just added how did you get that?
No problem. Multiply those two numbers.
Okay, so you didn't multiply the 598.
You said, did I? Yes.
Yeah, so you just do the 6 point. So you do 6.2 plus 0.366.
Oh no, you multiply these two numbers first. 3.66 times 598.
Oh, okay. I'm
Yeah.
sorry.
Oh no, you're fine. And then you get the 21.8868, and then you add that to 6.22.
Okay, thank you.
Okay, yeah, no problem. Move the decimal point. At what step? Well, basically, it's like this. When you multiply this, now that would go back into, if you want to do it longhand, doing this and multiplying it out. And so you would count out how many decimal places are and stuff like that after you finish multiplying. But you can just throw it in the calculator. So we're not asking you to do it by hand. If you were to throw this in the calculator, you should get 21.8868. And so
I'm getting 218.868. I'm not getting the 21.
All right, hold on 1 second.
Okay, maybe I'm probably doing something wrong.
All right, hold on. I might have let me see. 0.366. I might have wrote something wrong. Give me a second. Because I got 4 decimal places here. I got 3 here. I could go look up the book, but I'm good. Let me see. So let me see. It should be. I'm thinking I might need a 0 right here. Let me see. 0.0366 times 598. So I may have left off a 0 right here. That's what it's looking like. 0.0366. Let's see, somebody sent something in the chat. Okay. Oh, okay. You're just confirming what you're saying. Okay. Yeah, I can confirm it real quick. But looking at the calculator, I probably left off a 0 in the notes right here. But I can confirm real quick. So give me 1 second. While you guys are copying. Let me pull it back up here. If you'll let me. But any questions on the process outside of that decimal value? Just want to make sure I'm okay with what that problem was asking of me. I'll confirm this number.
So once we get the 218.868, we do 6.22 plus that, and that would be the answer for the problem. Thank you so much.
Yep, no problem. Just going up some. Waiting for this page to complete. Here we go. Right. Yes, I left off that 0. So it's right now. But initially I left off the 0. So good save, guys. Appreciate it. So once again, you didn't see I left off a 0 right here. And so it's right here is where I put it there as well. And now you should get the 21.8868. And all your calculations should work out. Thank you much. All right, so anybody still copying the red? All right, so now, well, your answer this answer is correct. I did all the work and I left off the 0 just for note purposes. So when you multiply these two numbers together, you get 21.8868. And then when you add them together, you get 6.22. All right. Is everybody good with that now? Okay. All right. So once again, in this problem, they gave us the regression line. So you wouldn't have made this mistake because they would have gave it to you. Well, unless you wrote it down wrong like I did, right? But this is the formula for actually finding the regression line. Now there are two ways of doing it. Let me see. Oh, excuse me, hold on. Yep, they did this way. So they could give us the whole data set, or they can give us the numbers to put into this formula, these formulas, and then calculate. So the first one, they give us the numbers to put into these formulas. And then the next one we'll look at just putting the data set into something like easycalculation.com and then find our regression line. So we'll talk about it as we get to it. But here we have our slope being R times S sub Y with S sub X. Now S sub X is going to be the standard deviation of our explanatory variable. S sub Y is the standard deviation of our response variable. So it's a little further down. Just giving everybody a chance to copy this part before I scroll all the way up. And we talked about R last class. That's our correlation coefficient. And this stuff will be labeled when they give it to you. So you'll see it in the next example. Y bar is the average or the mean of our response variable. X bar is the mean of our explanatory variable. And notice you have to find B first because B is a part of calculating A. So, and then our regression line will be A plus BX. So that's how that would be done for us. Like I mentioned, SD is standard deviation, just short for standard deviation. This is correlation coefficient. Okay, scroll up. Let's see. Response and explanatory. So EXP is explanatory. RESP is response. VAR is variable. And the next might be after this example, it'll give you exact differences between both of them, doing a straight comparison, but that comes in the next section. That's part of this. I'll scroll up. And if I go up too far. So I know this might look like a lot. So it's up to you if you want to copy all of it, but it was even more than that. That's why I put these three little dots right here because it's even more than that. But at least for board purposes, I wanted to put it up here and say what the problem actually gave us. So we have a college in the U.S. use SAT scores to help decide whether applicants, which applicants to admit. To determine whether the SAT was useful in predicting success, the college examined the relationship between SAT scores and first-year GPAs of admitted students. Let's go up some. So we have the average math SAT score of the sample was 649.5 with standard deviation of 66.3. The average GPA was 263 or 2.63 with standard deviation of 0.85, 0.58. Let me erase these circles. All right, then the correlation between them was 0.19. All right, scrolling up. And so in A, it says find the equation of the regression line, and they gave us the SAT was X and the GPA was Y. So it's letting us know that, once again, I'm going to give you, this strict comparison between your explanatory variable and your response variable, what it actually means. But at this moment, they hadn't gone into that yet. So they said X is your SAT, Y is your GPA. So that's why I had the red circles over these two. Those were your SATs and your SAT information. And then here was your GPA information. So they actually told us that. Then tell us to use the equation to find the predicted GPA of a person with the SAT of 650. All right. So here I just wrote down all the given information before I plugged it into anything. So they told us that the mean of the SAT scores was 649.5, the standard deviation 66.3. Mean of GPA was 2.63 with standard deviation of 0.58. Then the correlation was 0.19. So now to find B, we use the formula R times S sub Y over S sub X. And so that's what we did right here. And we got that number, 0.001697. Any questions? Any questions? All right, so that's B. Now to find A, that's Y bar minus B times X bar. So Y bar was 2.63. B goes right here, 0.001697 times 649.5. That ultimately gives us 1.53. Then from there in green, that's the formula for our regression line. Y hat equal to A plus BX. And so our A was 1.53. B 0.0017. So MATLAB will let you know how many decimal places to round this off to. I went 0.0017, and then that's times X. Now they could put it in word form like that first regression line that we had. So your Y was the GPA, so this would be predicted GPA. And our X was the SAT. So notice we just substituted it in for the X and Y hat. All right. Questions before we go any further?
I have a question.
Mhm.
Am I able to stay back when you're done? Because I'm still kind of not getting it, but I don't want to hold everyone else up.
Well, what is it that you're not getting? It might be helpful to somebody else. Is this something like small? You sure don't want to share?
The 0.19, you're multiplying that by 0.58 and then dividing 66.3.
Yeah, so if you want, because this is in parentheses, what you could do is 0.58 divided by 66.3 first, and then multiply it times 0.19.
Thank you.
Okay, no problem. So that's all you need? Okay. Yeah. If you have any problems or questions with any of the calculations, feel free to ask. Feel free to ask.
So when I'm doing that, I'm getting I'm getting 0.00166,214.
When you finish this off, you said when you get
Yeah,
the whole thing. All right, so let me see what's going on.
unless I'm doing something wrong.
Right, nothing wrong with checking. I don't have a problem with that at all. But you did get 0.0016, right? Like that first part, and it was a little different after the
Yes.
six. Yeah, so it depends on where you
Yeah.
round it, if you round it, and when you round it. So now what's going to happen is when it comes to MATLAB, they're going to tell you what decimal place. And so they may not go as deep as I did here. So you probably go right here. So you'll probably be fine. It's just that I went a little deeper in my numbers and I was trying to be as precise as possible. So depending on rounding and stuff, your numbers may not match up as stuff. As long as you have like the first four numbers, you'll be all right. And stuff like that. So they give you like in MATLAB, they give you like a leeway, like they don't show it to you. Like, but when I look at the answers, they'll do like a plus minus 0.0005, you know what I'm saying? Something like that, wherein they give you leeway with those decimals, So as long as you got 0.16 something, you're fine.
Okay, thank you so much.
Yep, not a problem. And I'll say this too, I'm glad you said that. whenever you're taking a test or doing something along those lines and you get a number that's close, but it's not exactly the answer, especially when it comes to tests, make sure you let me know. You can always shoot me an email on those things. I can go in and change the test scores or adjust scores accordingly if you actually got the answer right or you were real close and something along those lines. So always feel free to email me on stuff like that. Well, you don't always necessarily round up, you round according to what you have. So if I had 1.623, then I would have rounded to 0.0016. But because it was 0.1697, I rounded up to 0.17. So it depends on what numbers you have. Okay, cool. So, there we go. All right, anything else before we go to B? All right, so now B, they said that, let me go back to the problem, about use the equation to find the predicted GPA of a person scored SAT of 650. So you're gonna plug in 650 for the SAT and see what number you get, and that's gonna be the predicted GPA. So we plugged in 650 into the equation, and then what we got out was 2.635. So the prediction is that if you score 650 on your SAT, you will get 2.635 as a GPA as your first year, in college. And that prediction is based on previous observations. So what people did in the past is what created this regression line, which allows us to predict what will happen in the future. Questions before we go to the next piece? So, you see that we have some questions about, the process and everything. So make sure you try the stuff out on your own so you can know what question to ask when you come into class or come to the office hours and everything like that. Because, just with calculations, some questions may arise. Always feel free to ask your questions. And if anyone still needs to stay back because they had questions, feel free to do so. All right, so we're still in 4.3 and we're going into choosing your X and Y and order matters. And I'm about to go to another page, but let me know if I cannot. Is everybody okay for me to go to the next page? All right. Here we go. All right, so here is the difference between the explanatory variable and the response variable. So your explanatory explains the value of the response variable, but the response variable is explained by the explanatory variable, basically responds to the explanatory variable. Explanatory will always be X, response variable will always be Y. Explanatory is your domain, response is your range, input versus output, independent versus dependent. It's your horizontal axis for your explanatory variable. Your response variable will be your vertical axis. And your explanatory is your predictor, where your response variable will be your predicted. So whatever you're trying to predict will always be your Y, will always be your response variable. Just like in the last example, they're asking us to predict the GPA. So that's a clear indication that the Y variable is the GPA. Anyone still copying? I can go to the next page. Everybody good? Everybody good? All right. Oh, let me do this. Let me go back. Oh no, I may have on this other page. Let me see. No. Let me go back here. Just give you an example. Okay. So here, just want to show you a quick example. Talking about your explanatory variable versus your response variable. I believe we used this to find the correlation coefficient in the last class, but the club head speed of a golf club versus the distance. So you're talking about how hard you're swinging the golf club would dictate the speed of the golf club head. So, you know, if I'm swinging 100 miles per hour, the ball goes 257 yards, but if I swing it harder, the ball goes further. So in other words, the distance the ball travels is responding to how fast I swing the golf club. And how fast I swing the golf club explains the distance that the ball is going to travel. So that's what we're talking about, explanatory versus your response variable. One should explain what's happening in the other one should be responding to what's happening in the other one. So that's why they call it explanatory versus response. So that was it for 4.3. And so 4.4, if I'm not mistaken. Okay, yeah. So it starts off talking about pitfalls to avoid when it comes to evaluating the linear model. We're talking about your regression line. So these are just different things that MATLAB may ask you, you know, when you start talking about the pitfalls. So first of all, you don't fit linear models into nonlinear associations. So a regression line is only for linear models. So in other words, it has to be a line, best summed up by a line. Remember we talked about other patterns that are out there, you know, whether it be like this or like this, there are other patterns out there, but they're not straight lines. So if they're not a straight line, then the regression line equation doesn't fit for it. So we wouldn't use the regression line for those type of things. And remember, that's all we're talking about in this class, are patterns that fit the linear model. Remember, we also talked about correlation is not causation. So just because you have a strong correlation, does that mean that that's the cause of what's going on? But it is a reason to, you know, pique your interest, maybe need to do more research. Remember the example we used with liquor stores and violence. Just because there are liquor stores where there are violence and there's a correlation to it, does not mean that if you remove liquor stores, then all the violence will cease. You know, it's just something to look into. It's something that will cause a red flag or at least a yellow flag for you to go in and do more research into the cause of violence. And if liquor stores play a role in it, but it does not mean that it has anything to do with causing it. Beware of outliers, because outliers can most definitely affect your regression line. Always want to be careful for the regressions of groups of data, aggregated data. It can be used for that. And it says don't extrapolate. So in other words, don't make predictions beyond the range of data. One example they used was talking about the height of children and then the height of teens, you know. So in other words, you can't go off of, you know, 0 to 12 and then 13 to 17 because the age, not the age, but the heights start to vary tremendously because of puberty kicking in. So that's why I say don't extrapolate, don't make predictions beyond the range of data. So once again, these are just things to be concerned, you know, to make sure you're careful with when using your regression line. All right, can I scroll up? Got one more thing to talk about, and that's the coefficient of determination. Make sure you guys are done copying before I go to the next page. Anybody still copying? I'll go to the next page. All right. All right, so let's look at the coefficient of determination. This is 4443 is from our other class, 245. This is 44 for us. Still in 44, I should say. Coefficient of determination. It measures the proportion of the total variation in response variable that is explained by the regression line. It basically tells us how reliable the regression line is. So we would be able to calculate it by finding the correlation coefficient and then squaring it. It is denoted by capital R squared. All right, it's between 0 and 1 inclusive. If the coefficient of determination is equal to 0, the regression line has no explanatory value. If it's equal to 1, the regression line explains 100% of the variation in the response variable. Scrolling up. So for this next example, we want to determine and interpret the coefficient of determination for the club head speed versus the distance. Scrolling up on the block. So first thing you want to do is find the correlation coefficient. That's what we did in 4.1. We did the club head speed before versus distance. So not gonna do that all over again. You already sat through that. But that was when we went to easycalculation.com, typed in the values, hit enter, and we received this value right here, 0.939. So that came out of 4.1, same process. But that's the first step, because in order to find the coefficient of determination, we then have to square the correlation coefficient. And so 0.939 was our correlation coefficient. We squared that, got 0.882. And then converted it to a percentage, that's 88.2%. Just move the decimal 2 places to the left. But to 2 places to the right, not there. Any questions before I scroll up? So the interpretation of 88.2% as your coefficient of determination says 88.2% of the variation in distance is explained by the regression line. 11.8% of the variation is explained by other factors. And so you get the 11.8% by subtracting 88.2 from 100. So that's where you get that number from. And so we talk about other factors, you are hitting the golf club outside. Could you win? Anything here, maybe you hit a bird during that golf swing. Maybe you twist your hips when you normally don't twist your hips. Something along those lines. Something different occurred, which makes the regression line unreliable according to predicting the value at that moment. It's not going to be 100%, but this one is 88% reliable, which is a good percentage for prediction. And that just says the regression line has 88.2% reliability. Questions on anything? Has everybody done copying? Okay. So you guys don't have any assignments, not doing that for the summer. So we're just talking about what's going on here in the green box. What we've covered up to this point, chapters 1, 2, 3, and 4. Most of you got those definitions to me. If you have not, make sure you shoot them to me as soon as possible. For those who did shoot them to me and I haven't gotten them in the math lab yet, if I told you that I got them, I sent you that email back in response, then you're good to go. You don't have to worry about anything. I just need to type them into math lab. But at this moment, you guys have test 1 that has been posted. I'll be posting test 2 shortly. which is just on chapters 3 and 4, that you will be able to do on your own, just like test 1. And that's where we are. Next class, I'm gonna open the floor for questions first, see if anybody have any. But we are not having class on Monday because of Juneteenth. So I have to do 1 or 2 sections out of chapter 5 next class, since I won't see you until next Wednesday. So just want to throw that out there on what we will be doing next class. I'll open up the floor for questions first, see if you guys have any. But then we'll do 1 or 2 sections out of chapter 5 with the idea that, Monday is a holiday. And so I won't see you till the next Wednesday following. So, all right. So questions on anything before we close out today? Anything, anybody?
I have a question, but it's more about the textbook than the content that we just learned.
Okay, so let me hold on a second. Let me make sure everybody's done with content. I'll let people go that want to leave, and then you can stay back.
Okay.
Yeah. And okay, want to talk after class? Yeah. Miss Simone, I'm waiting for an answer from the dean to see if he has a suggestion or anything. So you work on your end, I work on my end. We'll see what we can figure out. That the thing that I sent you an email, did that work out okay? Just to give you the extra time that you were looking for? You feel free to just type yes. And then Brittany, yes, we can talk after class as well. All right, so before I go into personal issues, everybody done with class stuff? Before I let everybody out? Everybody good?
Sorry, I didn't feel like typing it. When the email, I emailed you back after what you sent me. I had spoke to financial aid, and financial aid don't cover my books.
Okay, hold on one second. Hold on one second with that. Give me 1 second. So everybody else is good though? So I can hit everybody. Everybody good? Okay. All right. So if you guys are good, I'm good. I will see you next class. I'm going to stay back and make sure everybody else is straight with individual stuff, and talk to you after class. Talk to you next class. You guys have a good one.